Good morning, boys and girls. Welcome back. Today we're going to talk about separable differential equations. Okay, given a differential equation, can we separate variables to find both the general and the particular solutions? Okay, to those equations. So let's go ahead and dive right in and get started today. For our first problem here, we want to find the general solution to this differential equation. All right. So the first thing we're going to want to remember is that y prime is equal to dy dx. This will allow us to be able to separate our variables. What we're going to want to do is be able to get all the x's on one side and all the y's on the other side. Okay, we want to kind of separate them. And generally, we're going to want y's on the left-hand side and x's on the right-hand side, because that's just the way we write things. So to get to this step here, I divided both sides by y, and then divided both sides by x, and multiplied by dx. It's very important. We can have variables be on the bottom of fractions like these, but you always want, you don't want a dx on the bottom of a fraction. You want that on the top. So you definitely want to multiply the right-hand side by dx, or both sides by dx, to get that up on the top. But we want it set up so it looks like this. This way now we can integrate both sides. And when I integrate, I'm going to integrate the left-hand side with respect to y, and I'm going to integrate the right-hand side with respect to x. This is why our differentials are so important, because they tell us with what variable we're integrating with respect to. So the antiderivative of 1 over y would be ln of the absolute value y, and the antiderivative of 1 over x would be ln absolute value of x. Now you might be saying, hey, these are indefinite integrals, Mr. Mortara. What about the plus c? Okay. Well, now, true statement, I should have a plus c after both of these indefinite integrals. But we tend not to put plus c on both sides like that, so I left them off because I wanted to talk about it. If I have plus c on both sides, eventually I'm going to try to get y by itself first so we can find our original function. I would end up minusing this c from this c. And really, I guess if I'm writing those, I should have c1 and c2. These are two different constants. Okay? And when I move this constant to this side over here, I'm still going to end up with just one, again, another brand new constant. I'll call it c3. Okay? So we don't get so confused here. What we do is when we integrate, we just put 1 plus c at the end of the second one, and then I don't have to worry about that plus c. But really, that's what we did, is we just moved the 1c to the other side. And now that we've integrated, what we're going to want to do is we now want to start to solve for y, and get y by itself. So our next step would be to exponentiate both sides with the base of e to get rid of the ln's. Okay, so on the left-hand side, when you do e to the ln, we know that cancels off, and that's why we did this whole thing in the first place. Again, keeping my absolute value. On the right-hand side, all of this now is in the exponent. Okay, be very careful with this. You cannot kill that ln off because of all that is in the exponent. Okay, this is not e to the ln absolute value of x plus c on the very end. The plus c is in the exponent, and watch out, that's a common mistake we will make as we, that plus c drops down. So don't let that happen to you. All right, now that we get here, what we can do is we can use our power rules to rewrite this a little bit. When you multiply bases, you add exponents. So I'm just using that rule that I'm going backwards. Because my exponent is being added up here, I can bring this down and I can rewrite it with two separate bases and those being multiplied together. Now, when I've got e to the c, again, c was just some constant, and now e to the c would be some other constant. So we can rewrite this as the absolute value of y equals e to the ln of absolute value of x times c, or the absolute value of y equals c e ln absolute value of x. Now that we have done that, we can take this again, and now I've got this e to the ln of x, so that could cancel off. And so now I've got the absolute value of y equals c absolute value of x. And now all we got to do is work to get rid of the absolute values on that y. All right, so this is where we're going to have to take a quick side note to do a little review, because it's probably been a while since you solved an absolute value equation. So here's a quick little review of absolute value. We know that absolute value makes everything positive. So if I'm looking at an easy absolute value equation like this, we know that, x could equal 4, because the absolute value of 4 is 4, or x could equal negative 4, because the absolute value of negative 4 is negative 4. If you remember, when we solve absolute value equations, we get something a little more complicated here. If I have an absolute value equation like this, what we did was we set up case 1, case 2. Okay? Case 1 was basically what we did right here. What if all this stuff inside the absolute value equaled a positive 7? Okay? Then when you took the absolute value of that, you would get 7. And case 2 is, hey, what if all this stuff inside here, whoops, don't need that, equaled a negative 7? Then when you took the absolute value of that, it would also equal 7. And then we went and solved these equations, and that's how we got our two different solutions. Okay, so that's a quick little review on how to solve absolute value equations. We set up this case 1, case 2. Now we're going to have to take this and apply it to our differential equation problem that we were working on. All right, so this next part now is where it gets to be a little bit confusing. I'm going to say, and it doesn't help when you look in even some math textbooks, their notation gets a little sloppy about what's happening. So I'm going to try to make this clear kind of what we are doing. Using our rules there, if I'm going to solve for y, technically I need to say, my two cases, y equals c, absolute value of x, or y equals negative c, absolute value of x. And now you might be saying, why do I need two cases if we got this c in front, a positive and negative, when c is just some constant and we don't even know what it is in the beginning, all right? And here's kind of why. This c, again, if we kind of backtrack in our work, comes from this e to the c, right? And when you have e to the c, e to the x, e to any power, that is always going to be a positive number. This has to be positive, okay? So this c value down here has to be positive, and therefore I need a positive or a negative c. I have to do this two-case thing. Now, really, we don't have to deal with two cases now. That's kind of confusing. Again, this is just some constant. So really what we should do is come, and I'm going to just say, hey, y equals a, absolute value of x, where a equals a positive or a negative c value. And now a can represent any number. Again, it's just that some constant. This is where, again, you'll see people get a little bit lazy and things. They'll just keep this c, and they'll still call this a c value right here. It's actually, again, a different c. But I have found that kids get confused over the years with, what happened to the c, and why is it a c, and how can I just drop absolute value for no reason? So to help us to keep from being confused, I'm going to encourage you, when you get to this step on a problem like this, do what we just did right there. I want you to change it to an a, and then off to the side, right, a equals plus or minus c, and that way you're at least kind of halfway showing why we can just drop absolute value, okay? We're really solving this absolute value equation. It's not just disappearing out of nowhere, but we're going to make it an a so that it can be a positive or negative c value, since e to the c is technically our c, and that should always be positive, all right? I hope that makes sense, and if you need me to, I can go over that a little bit more in person. Now on this problem, if that wasn't bad enough, I now got to get rid of the absolute value around the x. So again, I would say technically I would divide both sides by the a value, and I would have to do that two-case thing all over again. So we could say that x equals 1 over a times y, or x equals negative 1 over a times y with our two cases. And now again, this could just be some new, we did the same thing. Hey, let's say b is plus or minus 1 over a. We could do this all over again. We could play this game all day. So, to keep things short, all right, and so I could say now, x equals by, and now I could solve for b, or solve for y again, so y equals, 1 over b, x, and now I could call this, again, I'm going to go back and call that c, because this is normally what you would see. Again, c is just all these things, the a's, the b's, the 1 over b's, these are just some constant, okay? So normally you're just going to see this c, but that's why I like going from this step back up here. If I were just to skip all that and just go to y equals cx, you'd be like, what happened to the absolute value? Well, this is what's happening with the absolute value, all this work we did right here. And again, I believe if we show this work, at least with the a the one time, and you can just drop both at the same time, I would say, if I were doing this problem normally, and say y equals a x, where a is plus or minus c, I think that's going to be the easiest way. I hope I haven't confused you too much, and hopefully this makes sense why absolute values just appear. But this would be the general solution now. Y equals cx is the general solution to this differential equation. Okay, on the last problem, we had to find the general solution given the differential equation. Here, we're given a different equation, and they ask us to find the particular solution, or solve the initial value problem, where they give us the initial value. So you do this the same way. You're going to integrate, you're going to get your, plus c, your general equation, and then you're going to have to just plug in the point at the very end to find that c value. All right. On this one, though, I'm trying to keep this video short. Usually I let you guys battle with this a little bit in class, but I'm going to tell you there are some things that you can't separate. This is a problem where you can't get the t's and y's away from each other. It's impossible. So there are some that we cannot do still. And so this is not separable. Okay? So some problems we can't do. But if we could separate it, we'd separate it and then plug in and find c at the very end. All right, on that last one, I just had another thought real fast. If you want to play with that and try to separate the variables, it might be kind of good for you. If you were able to separate the variables on that. Again, I said it's not separable, but if you could, I'll give you an A in the class. Okay? So have fun, try to do it, but I promise you won't be able to. All right, number 3, last one here. We want to, again, separate variables to solve this initial value problem. We're given our differential equation, and we're given the initial value, and we want to come up with the one. So we're going to start out by separating our variables, getting y's on one side and x's on the other. So I would subtract root x from both sides, and then multiply both sides by dx. And so now I got just y's on the left-hand side and x's on the right-hand side. Now we're ready to integrate both sides. Okay, so to do this, I would first rewrite it so we are in exponential form, so I can use my, reverse power rule. Add 1 to the exponents, divide by your new exponent. Again, we only add c to the right-hand side. Again, there should technically be plus c, but we only put it on the right-hand side. And then I simplify this, and I divide by 3 halves, so I made it 2/3 y to the 3 halves equals negative 2/3 x to the 3 halves plus c. All right? Now we more or less have the general equation right there. Oh, and I forgot to mention, on this one, they told us to leave it in implicit form. So again, implicit forms means we don't have to get the y by itself. Implicit forms, we can kind of just leave it the way it is, right? But now I would say we are ready to, or about ready to, plug in our point to find out what the c value is. And I say about ready because I think I would make these last little adjustments to my equation before I plug in my x and y values. I first am going to take the negative 2/3 x to the 3 halves, and I'm going to put it on the same side as the y. So I have 2/3 x to the 3 halves plus 2/3 y to the 3 halves equals c. That way it's going to be easier to find my c. It's already all by itself. And then in this case, what I can do is I can also go and divide both sides by 2/3. If I divide everything by 2/3, that just becomes x to the 3 halves, so a little bit nicer to deal with. Y to the 3 halves, nicer to deal with. And then c divided by 2/3 is just going to be, again, another constant, some other c. So we can just leave that being c, and so that tidies that up a little bit. It makes it a little bit easier to deal with and work with. But now with this equation, I'm now ready to go back and grab my initial value, that y of 1 equals 4. So if y of 1 is 4, then that means my x value is 1, and my y value is 4, and I can use this now to go ahead and solve for c. Sorry, I had something pop up there. I'm not really sure why. We can go ahead and finish this now. 1 to the 3 halves is 1. 4 to the 3 halves, again, this means, the square root of 4, which is 2 to the 3rd power, which is 8, equals c. So now I know that c has to be 9. Okay, so this was the general equation. If they ask you to find the general solution, I would say. And now, if I go back and plug in the c, x to the 3 halves plus y to the 3 halves equals 9. This is the particular solution to the equation. Okay, and in this case, again, they said leave it in implicit form, so I didn't have to get the y by itself. But if they don't say leave it in implicit form, then you would want to go and solve for y at the very end. All right, boys and girls, I hope you enjoyed this lesson. I will see you again very soon. Take care of yourselves. See you later.